Hey guys, sorry about that. Just had a couple of issues with the headphones just dying out. So what we're doing today is carrying on with our tutorials that we've been doing so far. I just need to find there it is. So if you guys, I tried something yesterday with the level 3 guys, and I might try that with you guys as well. So that's the exam paper that oh, is it actually messing up again? I kind of can't hear myself. Yeah, it's been doing something really weird in my headphones, so I'm not sure why. Anyway, I've put the paper up there, the exam paper. So if you guys want to have a look at that exam paper and just shout out to me which questions you guys want me to go through, I'm happy to go through it. Just because like it is an old paper, some questions may be like too straightforward for you guys. And so I'm aware of it. But at the same time, like, we've only got like an hour, so I might as well do questions that you guys want to do again. Really? Sound issues again? Jeez. I have, yeah, I can hear myself, going in and out. Like, I don't know why that's happening. Uh, Trying to think what else could I do? This could be too much interference, maybe. Wow, it's really bad. Um, I've got a headphones that's a Surface headphones which connects to the computer. It's Bluetooth mic, so unless now I gotta go buy me a new mic, man. What's Trying to figure out, like, do I have another set of mics somewhere? I noticed you did that in some of the papers as well. I might just have to play it for the end to do apologize if things. Jeez. Okay, I think I do have to find another mic. Testing, testing. Okay, let's remove a few things so that there's no interference coming. Yep, all of that. That's all gone. What's the other way I could do this? Let's try this. Keep doing that sound check, man. How are we going? No problem so far. Still good. Still good. We're good. Okay. Problem one fixed. Problem two nearly done. Anyway, while you guys are waiting for things to load up, as I said to you guys, I'll put up the link for the exam paper. So if you guys want to have a look at the exam paper and just shout out any questions you guys want me to work on, I'll start working on them. Otherwise, I'm happy to go from 1.8 onwards. Yes, 15 minutes to actually. It's frustrating because I had everything ready at 7:20 today, and I was like just chilling out, waiting for 8 o'clock. And there we go. Absolutely wasted a lot of you guys' time. So apologies about that. Cool. So I think my sound is good, Rao. Let's get going. What should we just get going with 1A onwards, or do you guys want to pick a couple of questions from this paper? Okay, I'll try the whole paper, but I think we probably will do like maybe one or two questions, maybe question one, all of it. And then after that, yeah, like I said, Sky, we'll do question 2F after that. So we'll start off with some achieved questions. As usual, guys, I'll be recording at the same time as explaining to you guys. So we'll start off with a nice simple one, and then yeah, if people want merit and excellence, I'm happy to do that as well. Cool. So have a go at this one. Just a quick kind of 2-minute starting question. And then after that, we'll start doing the merit and excellence questions. Yep, got that, Ekamjeet and Sky. I'll keep that in mind next, yeah? So guys, I'm going to give you guys another 30 to 40 seconds on this, and then I'm going to go through the answer. There you go, you got a couple of 19s popping up. So just kind of going through question one here, what we've been given is we've been given f of x, and the question is actually asking us the gradient when x is equal to 3. So basically what we're looking for is f dash of 3. So we've got to work out what f dash of x is. Now f of x is 4x squared minus 5x plus 2. So if I differentiate it, I'm going to get 8x minus 5. Substitute 3 in. So I've got 8 times 3, take away 5. And that's going to give me 19 for a straightforward achieve. Now, a really good thing for you guys to keep in mind is checking that on the calculator. So if you just go into your main menu and just normal run mode, click on option, click on calc, and there's a button here called d of dx, which is F2. So you click on that, and then you type your equation, which is 4x squared minus 5x plus 2, and what we're looking for, the gradient at 3. So we're just going to put 3 in there, Quick way to check your answer. Yep, that's 19. Cool, good, move on. But please don't get into the habit of writing just the answer, because if you want to get that achieved, you have to show this particular line here to get that achieved. Cool, that's question 1A there. So you guys wanted to try question 2F. All right, Sky, we're going to question 2F right now. Now, don't, how do I say this? Like, I know that when some people kind of get a little worried about like when they see excellence questions in calculus, and I'm going to be honest with you guys, like excellence questions in calculus is a lot more, like, it's a lot more comfortable than what you say, like the algebra excellence questions. So let me just have a look at 2F. I can't remember which one it was. That's 2E. That's got to be 2F. Okay, here we go. So this is question 2F here. What I'm going to do for you guys is, as always, I'm going to give you guys like a few minutes to kind of have a go at this. And then like once you kind of have a go at it, then I'll actually kind of work through with you guys. Again, remember that this question is an excellence question. So even going to particular points in this question is actually going to get you an achieved or a merit. So just keep that in mind. And yeah, so have a go at this question. I will go through the answer at about 8:28 because it is an excellence question. I'm going to give you guys a bit of time for it. It's funny you should say this, Peter, because like I'm having a look at some of the old papers at the moment. And to be honest, the questions back in the day was just like so much more easier than what you guys have to go through. I mean, you guys go through the trenches. Renee, I know that you took that message off, but like I remember I only figured this out quite recently as I was kind of playing around with the calculator. And I've been using this calculator for what now, coming close to 22 years. So yeah, I've only discovered a few things recently. Now, just as a little hint, guys, if you are stuck in it, remember that when you have kinematics, you've got the distance, velocity, and acceleration. Going from distance to velocity, you've got a different shape. And then you got to go integration or anti-differentiation, as some people call it, when you go from acceleration to velocity and then velocity to distance. Silver Toad, I have to say that it has been a very long day because I had about 5 hours worth of enrollment interviews today. So that's me interviewing new people to coming to my school. So that was that. And then in the morning, I had to do some workshop. So I've been talking nonstop, been drinking a lot of water nonstop just to keep myself hydrated. Because I know last year, I think you guys were there last year when I did this, I lost my voice at the year 11 tutorial completely. Not a problem, Banana, as well. Like I knew that that was a big step up for you, but it's all good, man. I think you'll be fine with it next year, around this time. Yeah. By the way, thank you for asking, Silver Toad Gaming. That's pretty nice. Appreciate that, man. Yeah, I was supposed to go for a run this morning, but I was like, I kind of said to myself, right, I need to keep going till that last tutorial. Uh, what are you talking about, EasyVert? Which one are you talking about? Are you talking about just this question, or are you talking about calculus? You got plenty of time, lol, EasyVert. Plenty of time to um, get through these papers. Maybe I should focus. I should do like a tutorial, like how to pass level 2 calculus with the bare minimum. Nah, easy word. I don't believe that, man. You got 3 weeks to do this. You got plenty of time, dude. So nice. 14.271. Okay, that's interesting. Um, Retaliation. I'm going to give you a bit of a heads up, just to give you a little bit of knowledge on some grades, right? I'm going to be brutally honest with you guys right now. You guys know that I've been running these tutorials for like, I don't know how long, but I'm going to tell you this right now. Mark this time, 8/28/29. I failed the first 4 years of my university. I failed maths papers in my university. I failed like, geez, I failed my fifth form. Like, so year 11, I failed. Year 12, I failed. Year 13, I repeated twice. Yep, that's right. I repeated it twice, and then I failed in uni. But you know what? No one cares about the grades, man. I'm here, just doing my thing, and I'm enjoying it. So no one's gonna care about your excellence endorsement, if I can be brutally honest. Sorry, I know we're kind of like sidetracked, but let's actually get through this question, guys. Really bad habit of mine. Don't, this is why my students kind of like never learn anything in my class because I'm always telling them stories. Okay, I'm gonna sidetrack for a while here, but I'm gonna go through the question for you guys. So we'll record this. Um, okay, so what we've got here is a classic kinematics question, right? So with kinematics question, I always say this, draw a picture because God, I hate words in these calculus questions. I like pictures, all right? So I've got a car and it's on a road, obviously. So there is my ugly car right there. Just my Corolla going along nicely. What does it say? The car speed changes at a rate given by v equals negative point. So that's actually the acceleration. So this part right here, of course, it's not going to write. It's not going to show what I'm actually writing. God, talk about fails today. Hang on, let's just refresh this. Yeah, stupid, stupid. It really doesn't like you guys today. I don't know why. But I think I've got a hack to fix this. Come on, fix, fix. There we go, fixed. Here we are. So let's try that again. So with kinematics, what we want to be doing is just draw a little diagram, all right? So there's my ugly car, back again. Nice little Corolla there, chugging along. So the first part that's really important is this right here is acceleration. Now, if for any reason you guys actually don't know, is have a look at the units. And those of you guys that are doing physics would know that meters per second squared is, looking at that acceleration. So that's something really useful to have. So I'm going to write this down, and a is equal to negative 0.08 t. What else do we have? Our second bit of information is, so at some point here, so when t is equal to 0, the brakes are actually applied. So that's when the brakes are applied. When t is equal to 3, velocity is equal to 5. That part I actually got from this line here. So that's this right here. And then the question's asking how far will the car travel with the brakes applied before it stops. So what we're looking for is at some point in the future, the velocity is going to be 0. We want to figure out what's that time, and it's asking how far will the car travel, right? So we also want to find out what the distance is at this point. So that's, as you can see, like you've got like a couple of things that you got to actually work out. First, we got to work out when the velocity is equal to 0. And then once we have that time, then we got to work out how far. So that's like the distance equation that we need to put through. So with that in mind, I'm going to integrate acceleration. So when I integrate acceleration, I'm going to get velocity, which is negative 0.08 t squared over 2 plus c. By the way, if you guys do this, this actually gets you an achieved right here. All right, so that's what I mean by like when you look at kinematics questions, if you can actually do one step, you could come away with like an achieved, which actually ends up being like 2 points. Now, what do we know? We know that at 3 seconds, so velocity at 3 seconds is equal to 5, because that's the part that's actually highlighted in blue. So we're going to substitute 5 equals, now negative 0.08 divided by 2 is negative 0.04. T is 3 squared plus c. So we've got c is equal to 5 plus 0.04 multiplied by 9, because 3 squared is 9. And what have I got here? So I've got 5 plus 0.04 times 9. So that's going to give me 5.36. So once I have that c is equal to 5.36, my velocity function is negative 0.04 t squared plus 5.36. All right, so with that in mind, what do we got? I just need to double check a couple of things. Yep, we're good here. So once we got that, now we need to actually figure out when is the velocity equal to 0. So we need to go, so what is t when velocity equals to 0? So we're going to put v is equal to 0 and negative 0.04 t squared plus 5.36. Rearrange it. So we've got, when I bring that negative 0.04, it becomes positive 0.04 t squared. And all of that is equal to 5.36. So I can actually say t squared is equal to 5.36 divided by 0.04. So t squared is equal to 5.36 divided by 0.04. I am typing in no man's land. Where's my calculator? There it is. 5.36 divided by 0.04 gets me 134, which means my t is equal to square root of 134. And so t can be said as plus or minus 11.58. Now, we don't care about negative, the negative time. So we're only going to focus on the positive time, because the negative time is obviously somewhere here. And yeah, we don't really care about it. So we're just going to ignore that t as, so we're going to take t as 11.58. So basically, that means when we figured out t is 11.58, we're going to put this as 11.58 here. So that's what that t is equal to. So now we need to actually figure out what the distance is. Again, whenever you take like a square root symbol, you're always going to get plus or minus. That's always the case. But it's always like good to check with the context of the question. So in this question, we know that the brake was applied at t equals to 0. So we don't care about what happened before that time. And so that's why we choose to ignore the minus 11.58. So now I need to figure out what is the distance at 11.58 seconds. Now, what I have is velocity function, which is negative 0.04 t squared plus 5.36. So I'm going to integrate this. So when I integrate this, I'm going to get negative 0.04 t to the power of 3 divided by 3 plus 5.36 t plus c. Now, this part is quite important. In some cases, you guys will have to actually find out what the c is for the distance. But however, in this case, we're actually measuring how far is the car traveling when t is equal to 0 all the way up to 11.58. So what we can actually say is when t equals to 0, we can actually say that s is equal to 0. I might just write that in a different color there. So when t is equal to 0, we can say s is equal to 0. So that's what we're going to say, because we are measuring from when the car started applying its brake, so that was when t was equal to 0, up to 11.58. So now we're going to put 11.58 in this equation. So we're going to get negative 0.04 multiplied by 11.58 cubed. See, I can make these silly mistakes. And because I might actually just put this, t is equal to 0, s equals to 0, therefore c is equal to 0. And I'm going to put plus 5.36 multiplied by 11.58. So putting this in the calculator, I'm going to do a little bit of a shortcut, which is 11.58. And I'm going to leave that as answer, which means negative 0.04, negative 0.04. Multiplied by answer, which happens to be that 11.58 to the power of 3, divided by 3 plus 5.36 multiplied by shift answer. So as you guys can see, the distance that I'm going to get is 41.4 meters. So grades wise for this question, the final answer is going to get you, distance found is going to get you an excellence. As I told you guys already, you guys know to get achieved, you need to get that velocity function. And for the distance function formed, so I would probably say right here is where you're looking at merit. Actually, distance function formed, yeah. So or even up to this part here where you actually say that c is equal to 0. Cool. So like I said, for any kinematics question, the best way to do this question is kind of draw the diagram and then just work through one step at a time. Cool. We move on to the next question. All right. How about you guys? All right. Where do we go? Where do we go? Sorry, I'm just going to go back all the way to the top when I missed you guys with the question. I think the last time I talked to was retaliation. Yeah, Sky. Yeah, trust me, man. I got a lot more stories from where that came from. Silver, it's not about, it's okay to fail, but as long as you're learning, that's the important thing. Tilly, you got the right answer. That's all good. Yeah, that was the old one, so that's all fine. Talked about that. So confused. Sorry, Jonty. Jonty, if you are confused with the kinematics question, I've done like, I think there was a tutorial that I did last year. I can't remember which one it is, but like what you can do is if you go to my website, like where is it? Let me just find it. Just to give you guys a bit of like a little bit of a hint here and there. So go to my website and then go into whiteboard and go to 2020 whiteboard. Now, if you go to 2020 whiteboard, what's going to happen is you're going to get a OneNote document. So basically all of these files that I have here, they're all up online. So you guys can access it at any time. So under 2020, there we go. Look, bang on, I left it there. So if you look up this calculus tutorial 2 from last year, that covers everything to do with kinematics. So it might be a place for you to kind of start, Jonty, if you are struggling with, and same with you, I'm trying to see your name, is it CC Lore? If you go to that tutorial that I did last year, or even if you check the calculus tutorial playlist, if you go to 19th August 2020, it pretty much covers all of the everything you need to know about kinematics, and the notes will be on the 2020 whiteboard as well. Cool. Any other questions with this kinematics question, guys, before moving on? I'm happy to work out whichever questions you guys want me to. So I know Sky's asked for 3E, so I'll work on that next. Or do we want a little break from an excellence question and try a merit question first? Let me pick like an annoying, like, let me put you guys this question here. People actually get freaked out about this question, but in reality, it's actually a really easy merit question, which people kind of get stressed out about. This one right here. So this is a rate of change question, right? And I don't know why, but like a lot of level twos that I've spoken to, they kind of freak out about this question. So have a, let's try this one first before we go to that excellence one. Um, so John T, about the drawing graphs one. So this one is a little tricky. I tried it last year. I will try it again this year. I will create an activity on Desmos, which we will try and do together, all of us. So you guys can jump on Desmos and actually try drawing the graphs. I tried it out last year. I was very nervous about it, but I had about 30 kids that jumped on, and it was really cool. So yeah, can kind of do that. So yeah, we'll do that. I think I've got another calculus session with you guys anyway. When do I have another calculus session with you? Yeah, so next week, Wednesday, we'll do that. Do all the kinds of drawing the graph questions. Uh, what seems to be challenging you today? This question or just generally the papers? Yep, that's not a problem, man. Like, do I teach chemistry? God. How do I put this? Chemistry. Here's an inspiration story for you guys for chemistry. When I was in year 13, I was studying chemistry, and at that time we didn't have NCEA grades, so we only had like high, like we had marks, right? You had to get marks. And I remember in my first mock exams in March, I think it was. Yeah, we used to have mock exams in like actually not March, I think it was June maybe. I remember the kids, like we all used to go, oh, what did you get? Who got the highest mark and everything like that. Anyway, calculus and stats, I ended up getting like the highest mark in the school. And for chemistry, I got the lowest mark in the school. So yeah, hopefully that helps you. Alpha Adam is good. Yeah, that guy, caught up with him last year through some chats. He does some chemistry stuff. Go check out his work, man. But yeah, so please do not ask me anything about chemistry. Anyway, Uday, I know you're worried about this question, so I'm going to go through it, and I'm going to try and explain to you and at the record at the same time. But rate of change questions. So with what do we got here? So what we have here is like your classic rate of change questions. Um, so in this question, what we've got is we've got like, and I guess visualizing it always helps. Um, yep, so I've got like some kind of stone that's actually dropped into a pool, and you know how the ripple happens with the like the waves happen. That's what's happening here. Now it's asking what is the rate of change of the area of the ripple with respect to radius. Now these are the only two things I actually want you guys to have a look at. When they say rate of change, all right, what they're asking is how fast is something changing when something else is changing as well. So let me show you what I mean by that. So if we have like the way we write it is we write it like dA over dr. Now the A, that part right there is the area, and then the radius, which is the r. Now if you think about it, if you look at the original question, you've got the original formula, which is A equals to pi r squared. So all we're going to do is when a equals to pi r squared, we're going to differentiate it. When we differentiate this, we get dA dr, which means pi is a number, so we just leave it as it is. When we differentiate r squared, we're going to get 2r. So what we've got is pi times 2r, or this can be said as 2 pi r. So we're going to put dA over dr, or the rate of change, is just 2 pi r. Now the question, though, is asking when the area is 49 pi meters squared. So our first thing is we need to figure out, sorry, I'm just going to move this bit so that we can kind of have a little bit more room to work with. So this 49 pi, so remember that area is equal to pi r squared. Now the area is 49 pi, and we need to find out what is the radius. So what is the radius when the area is 49 pi? So just going to put that radius is what, and then area is equal to 49 pi. So this is what we're doing in the green highlighted part. That's what the green highlighted part is. So we kind of rearrange this. So we're going to get r squared. When I get rid of that pi on the other side, I'm going to get 49 divided by pi is equal to r squared. R squared is equal to pi's cancel out, and I've got 49. You could write this as plus or minus 7, but we know that when we're talking about radius, it's got to be a positive number. So that means this is going to be 7. Sorry, square root of 40. R squared is 49, so r is equal to square root of 49, and then r is equal to positive 7. So there's two parts to this question. The first part is we need to find out what is the radius when the area is 49 pi. So we've done that. The radius is 7. The next is we need to find the rate of change, which we've got the formula for the rate of change, which is this. And we know what the radius is when the area is 49 pi. So all we got to do is we just got to go 2 pi multiplied by the 7, which gives me 14 pi as the answer. Now you could leave it as 14 pi, or you could put it as 43.99 as well. Grades wise, you're looking at R found and rate of change calculated is going to get you a merit. So that's, you got to do this and this to get a merit. For achieved, derivative found. So for achieved, just this right here, just differentiating the function, the pi r squared, it's going to get you an achieved. All right. So really important that when you do see rate of change questions, if you see the word rate of change, you're going to have to differentiate something. All right. So whenever you see the words rate of change in your head, you got to go, oh, actually, yeah, that's the part where I got to differentiate. Have they got a formula? Yeah, they got a formula. Just differentiate the formula. You're going to get an achieve for it. And then go about trying to solve the problem, which means that you're actually going to end up getting a merit for that question. Okay, moving on. No, units are not required from what I can look at it. There is no mention of units at all, Drea. You can absolutely write 14 pi as your answer, Banana Swirl. John T, I wasn't good at maths in my first round of year 13. It was my second round that I really started kind of understanding everything, and suddenly I pretty much loved stats and calculus. In fact, I actually got top marks in stats. Calculus, I got like third or fourth. CC color, I'm assuming you're talking about the differentiation. So when you have, it's kind of like thinking about it like this. You know how you have, if I have like 3x squared, right? I would go 2 times 3 is 6x for the differentiation. So very much like that, pi is a number. And because pi is a number, I'm going 2 multiplied by pi, and then r just drops a power. Yes, John T, if you've been watching the end of my every video, I say this, especially with calculus, level 2 calculus, it's if you find a question that you don't understand, you just need to recognize whether it's a differentiation or integration, and then you just kind of do that. Let's see, am I good at physics? I was, not anymore. So do you just take the m squared out of 49 pi? Yeah, you don't worry about the m squared. M squared is just the units, Corin, that says that it's meters squared. Not that I know of, verified gamer. Um, I'll have a look, Peter, because normally they only have like one rate of change question in an exam. It's just the way it is. They don't have more than one. Not that I could see one anyway. Like, I mean, I could pull back an old question that we did just to kind of give you guys, what are we doing? We're doing calculus. Let's have a look, whether it's in 2020 whiteboard. Oh yeah, here we go. Might just see if I can copy this so that you guys can have a go at this question. Where the hell is copy? 2021. Here we go. One more rate of change question because you guys want to have a go. Okay, so this is yet another um, merit question. Pretty much rate of change question again. So I'm going to give you guys like 3 minutes. Have a go at this. So Uday, I know you said that you were kind of like freaking out before. Have a go at this, man. See how far you get with this. And same with you, John T. See if we can try and get this through. Yeah, I saw the banana. You ran 5K. I um I haven't actually run for a very long time. I put like 4Ks on, what was it, Tuesday morning. Just got up and I was like, you know what, I'm gonna go for a run. But I really do miss my those epic 20K runs that I used to do. Brady, for the previous question, um, the answer would have been, because it was like this. Remember how we wrote dA over dr? That means the units would have been 14 pi. Area is measured in meters squared, and radius is measured in meters. So that's how you would write that as units um, for it if you were looking at it. So that's basically saying that for every 1 meter increase at that point, the area is increasing by 14 pi meters squared. But Brady, you don't need to worry about answers for, generally you don't need to worry about, not answers, units for these types of questions. They tend to be a bit more kind with that. Yeah, so you just put dAdr equals to, and then that's basically it. Mm. So just be careful with this question, guys, because you have to read the question. Yeah, I kind of figured somebody would do that. So we got a couple of answers there. 676 Tom, it's not yeah, man, once you go through a few of these questions, you'll be all right. Kanye, long story short, I moved here when I was 12 from India. Um, and then when I was 18, my parents actually moved to Australia. I decided to stay back. I had a suitcase and a sports bag worth of stuff. That's all I had, and maybe a couple of $100 in my pocket, in my bank account. And yeah, no, been Been growing up ever since then. Yeah, if you guys got that 2.5, you're looking solid, guys. Tilly, I'm going to ask you to go and read that second part of that question again because I think I know what you did, which I'm guessing. So, cool, guys. I'm going to chuck the answer up for you guys because I think you guys are all getting that 2.5, which is on the right track. But I'm going to show you why some of these guys are getting 2.5. And maybe if you're not getting 2.5, is because you might have misinterpreted the question. So let's have a look here. Our first step is that we got volume of a, it's a balloon, yeah, 4/3 pi r cubed. Now the question is saying, what is the radius? So what is the radius when the rate of change with respect to radius is 25 pi? So if I was to write that as a question, remember rate of change, so I'm going to put the d. I've got v with respect to r. So that means it's dv dr. That's what that means, that with respect to radius, what's the volume with respect to radius? It says, what is the radius when the rate of change is 25 pi? So dv dr in this case is 25 pi, not the volume, but the dv dr is 25 pi. So we've got to actually work out what dv dr is. So to do that, we just have to differentiate the function here. We've got 4/3 as a number. We're going to leave it. Pi, we're going to not touch it. R cubed is going to be written as 3r squared. What you'll notice is the two 3's cancel out each other, and you've got dv dr is equal to 4 pi r squared. Now, because these two things are equal to each other, we can actually find out what r is, because we're going to put down 4 pi r squared is equal to 25 pi. And of course, rearranging, you can kind of see the two pi's disappear. And what we've got here is 4r squared is equal to 25. R squared is equal to 25 divided by 4. And I'm going to be lazy and just not use my calculator here, because I'm going to do square root of 25, square root of 4, which gives me 5/2, which also gives me 2.5 centimeters. Yeah, so as you guys can see, this ends up being a merit question. Like, I mean, I always say, like, you know, like John T, I know you've been talking about it, and Uday, you've been talking about this. This is a 5-point question, man. Like, M5 is actually going to give you 5 points. And if you think about it, for the paper, you need 8 points or 9 points for an achieved. So let me, while we're at it, let's actually get that confidence up. I'm going to see if I can find the 2020 question. So, because every year there's one, right? So every year there's one. Let me see if I can pick up the 2020 question. At least that way. Oh yeah, here we go. Hang on, sorry, I know I kind of skipped through. I'm going to come back and answer that question. Let me just figure this out, how to place this so that I can answer questions and do things at the same time. I'm guessing that that might be a bit too small. I don't know if you guys can see the question, or do you want me to zoom in? But I'll actually zoom in, actually. It's all right. I'll just talk through the person. Can you go over how you derived in terms of the r squared? Okay, Hayden. So when we have 4/3 pi r cubed, right? So imagine it like this. You know how in differentiation you go axn, and a is the constant, you don't do anything to it, but you multiply by the power, and then multiply by x to the power of n minus 1. So my constant in this case is this entire thing. And my power in this case is just the 3. So if that's the case, then if I was to follow this rule, I'm going to get 4/3 pi multiplied by the 3, which is the original power, multiplied by r to the power of 3 minus 1. So remember, I've got to take away 1 from the power. So basically, that's what's happening here. So the two 3's, they're going to cancel out each other, and I'm left over with 4 pi r 3 minus 1 is squared. I got the right answer, but when I differentiated, I got 12 pi xr squared. No, I don't think you should get 12 because there's a third in the denominator. So unless you got 12 pi r squared divided by 3, then that's okay. Is it 14? Good question. I need to go back and just have a quick look. Which paper was this, calculus? Where is it? Where is it? '28. This is a little bit, this second lot of question is a little bit more trickier, but that's okay. I'll show you guys how to go through it. On the whale one, no, it's not 14. I'm trying to figure out how you got 14. 14 what? 14. 28 pi. No, could it be 28 pi? 2856? No, it's not 28 pi. Yep, no, that's okay, Jonty. I mean, that's the whole point of us kind of working through these types of questions, right? The radius is equal to yeah, no, I kind of figured that you guys would try and do that, but it'd still work. Yeah, man, pretty much 676, Tom. Yeah, now I meant to give you guys this question because there is the whole point of these types of questions is that there's different varieties. Now, let me ask you guys this question. I'm guessing that all of you decided to find out DADR. Is that correct? Is it going to show up? Yes, it is working. Because if you were trying to find DADR, in this case, it's actually not going to work. Why? Because let's actually break this question down, right? Like I'm going to break it down slowly for you guys, one step at a time. So we got a whale that surfaces, blah, 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 whatever. Circular ripple comes. Yep. So this is the same kind of ripple thing that's happening here. But it says that the radius of the circle is given by 0.7 t. So we're going to write that down. First off, 0.7 t. You're missing your full decimal point is kind of all over the place there, Banana. Do you want to check your decimal point? So that's what the radius is after the whale surface. Now the question's asking at what rate is, so we've got a rate of change, the area of water, but that's all they give us, right? At what rate? They're not actually telling us with respect to anything. Because if you look at the previous questions, where's my previous question? Here we go. Here, you can see volume with respect to radius. That's why we get dVdr. If you look at the previous question we did here, they said area radius, which means we're going to get dA dr. All right. But in this recent question that we're doing, they are actually not telling us with respect to anything. They're just saying rate. If it's just rate, then it's based on time. So that means we write this as dA dt. This is what we're trying to find out. We're trying to figure out what is dA dt when the time is equal to 20 seconds. Now, we're not trying to find, so what you guys figured out, for some of you guys that are putting the answer with radius 14, what you're actually giving me is you're actually giving me how much the area is changing with respect to r. You're not giving it with me with respect to the time of it, if that makes sense. All right. So notice how in the previous question, they always said with respect to radius, with respect to radius. In this case, there is no respect to radius, which means you're not doing dA dr, you're actually doing dA dt. But here's the kicker though. Like you're wondering, how am I going to get this? Now, here's the thing. We know the area is pi r squared. Area of a circle is pi r squared. But what we want is dA dt. If you differentiate this, you are going to get dA dr. We're not going to get dA dt. So what we need to do is get rid of the r and replace it with a t. And we know how to do that because we know that r is actually equal to 0.7t. So I'm going to get rid of the r and replace it with 0.7t. So my new equation is going to be area equals pi multiplied by 0.7t squared. Because now when I differentiate this, I'm actually going to get dA dt. Because look at this. I've got a there, which is my area, and I've got respect to t, where is my t here? But in the original equation, when I had the r, I had dA dr. Hopefully that made sense, right? So you had to kind of like adjust the equation a little bit before you even try and differentiate it. Because once we get to this part, then it's straightforward differentiating and substituting t equals to 20. So we're going to differentiate this, which means we're going to get, I'm just going to expand that bracket first. So area is equal to pi multiplied by 0.7 squared, t squared. So this is going to be pi times 0.49 t squared. So when I differentiate area with respect to time, I'm going to get 2 times pi times 0.49 multiplied by t. All right, so, or in other words, I can write it as 0.98 pi t. And because t is equal to 20 seconds, I just substitute t as 20. So I've got 0.98 times pi times 20. So me being lazy again, I can just go 20 times 0.98, which gives me 19.6 pi as my answer. There we go. Yep, 19.6 pi. So again, if you guys notice, right, like it's not that difficult. All you have to do is just differentiate and try and figure out what the question's actually asking. Is it asking for, are they giving you a rate of change and asking you for the radius? Are they giving you a rate of change and asking you to figure out something else? So it's always a good idea to write down these types of questions just to see what you guys actually have before actually attempting it. Yeah, and I think that's the biggest challenge, Peter, is that it's the getting started part. And that's why it's really, really important for you guys to actually go back and have a look at all the different types of questions that they've been putting up. Because that does help you. You know, you get to see like a variety of different types of questions, which actually increases your confidence a bit more. Why is it 2 pi instead of just pi? Because remember, 2 is the power. So I'm actually bringing the power to the front. And because pi and 0.49 is a constant, I'm simply going the power times the constant. And then, of course, t is going to be 2 minus 1, therefore it becomes 1. Oh, this is definitely a merit, yeah. This is not like uh, yeah, this is not like a achieved question or anything like that. And looking at it, hang on, I just want to have a look at this real quickly. This is 2020 paper. So an achieved is like up to here is going to get you an achieved, this part here, and merit is your final answer. How do you mean, do I have anything else on this? I don't understand, John T. You mean you want to do one more question like this? So what I like, yeah, I wish I had kind of I've not seen it come in level 2, man, because like in level 3, definitely you're gonna get like a rate of change question that's an excellence or a merit. But at level 2, I don't remember seeing an excellence question. Um, yeah. Okay, so I got time for one more question. So let me just go back to this paper because we kind of like, um, how do I say, we sidetracked in this paper quite a bit, but no, not that one. Oh, here we go. Here's a question. Look at that. There we go. Try that question. There's a rate of change question. I didn't realize it was actually in the paper. 2013B. 1B. Is it? 2B? Oh, no, this is not. I mean, it's called a rate of change question, but it's actually just an achieve, guys. Don't worry about that. See you later, Charlotte. No, no, no. This is simple, guys. This is just differentiate and put it equal to 0. But like, I guess this is a good time to actually talk about that rate, right? Because remember, this actually says find the rate at which the depth of milk is changing. So what they're asking for is d of d with respect to t. That's what they mean by whenever they say rate, but if they don't give you like respect to anything, then it's just over time. Generally, that's what it means. But now we won't actually do this question. Like, let me just see if I can find another. Uh, Actually, I might just do the last question, which is an excellence question. No worries, Corin. Unless, oh wow, it's actually 9:15. Jeez, I didn't realize that. Oh, right, 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 right. Now, actually, guys, I think I should call it because I didn't realize it was 9:15. Otherwise, I'll just keep yapping away and keep going. Um, that's all good, man. That you'll be fine. Just keep practicing away. What shall we do? We're gonna call it, guys, because I didn't realize the clock had actually gone well past 9:15. Um, so when do I see you guys next? Let's have a look. Where are we at? Cool, guys. I think I'm seeing you guys next on Monday for algebra. But yeah, I think I didn't realize it was actually quite late. So I will catch you guys on Monday for the next tutorial. And I will try and, how do I say it? Get everything charged and have everything ready to go. Nah, Suhaib, it depends on the question, man. Like, so some questions are achieved, some questions end up being merit. Um, yeah. Which one are you talking about, Ikamjit? Like the 20, the box question? I think it was L over 9, so you've got to kind of prove it. It's a proof question. So yeah, when I get some time, I'll actually sit there and make this because I'm about 3 videos behind at the moment. Is that the Shark Tank question? Let me just do it. I'm trying to do it real quickly in my head. Give me a second. So t squared 2t, t over 2 plus t plus 1. Uh, check out the answer schedule there. I'll pass the answer schedule for you guys so you can actually have a look through whichever question you're trying to do because I can't remember off the top of my head. So that's the schedule there. So have a go through that. Cam one, it's up to you, man. That's like asking, a goldfish whether they like to swim or run. It's really up to you. Yeah, I think it was 3.5, right? 1B? No, it wasn't 1B, it was 2B. 2B was 3.5. There we go. That's what you're looking at. Cool, guys. Have a good one. I'll catch you guys next week, and hopefully we'll have all the technology working then. See you. Stay safe.